and Gauss-Seidel method. Both these methods are iterative methods. Now Jacobi method, this method is simplest method, but this is lengthy. So this is easy to understand, but is much lengthy. In this, we are going to consider values of variables from same iterations, values from same iteration. But if we will go to Gauss-Seidel method, this is iterative method, but here we are going to consider latest value of the variable. Latest value of variable. Here we are not going to see these are from same iteration or not. We are going to take the latest value of the variable and then we are going to solve the problem. Now, in this, actually, in this method, our diagonals are predominant. So, diagonals dominant. Diagonals dominant. What does it mean? Means if we will say we have this will be A, B, C, then we have D, E, F, and then we have G, H, I. Then I can say in first we have mod of A should be greater than mod of B plus mod of C. Then we have mod of E in second should be greater than mod of D plus mod of F. And then mod of I should be greater than mod of G plus mod of H. Then only this method is preferable. Otherwise, we can use it, but this becomes very lengthy method. So now we will go with first method. So we have these two equations. So here we have to find out from first equation, we will find equation in terms of x. In second, we are going to find out equation in terms of y. So we have x 15 minus y by 3 and y 10 minus. So we have this as 10 minus x by 2. So now we have first Jacobi's method. First we will assume values of x and y 0 and these two we will put in this equation. So 15 minus 0 divided by 3 we have 5. And then here 10 minus 0 divided by 2 5. Then we are going to use x and y of this iteration only. So we will get value of x 3.33, value of y 2.5. For next iteration, we are going to use values from this. So we are using values of the same iteration. And likewise, we will put the values, and by substituting these values, we are going to get finally after in the ninth iteration, we are going to get value of x that is equal to 4 and value of y that is equal to 3. So in this way, we are going to get these two values 4 and 3. So these are going to be converging out towards we have 3.06, 2.99, 3.01, so 4.03, 3.98, 4 likewise. So now in Gauss-Seidel method, we have equation same, that is 15 minus y by 3 and then we have 10 minus x by 2. Now here in this equation, we are going to consider first that is value of y that is equal to 0. And by substituting value of y 0 in equation of x, we will get value of x that is equal to 5. Now in this, we are going to get value of x which is latest 5 in this equation. And we will get value of y that is equal to 2.5. So we will substitute value of y now 2.5 in this equation. Then we will get value of x which will be 4.17. Now put this value as x, then we will get y. So you try to understand in this, we are going to use value of y from first iteration and value of x from second iteration. So likewise, here we do not have values from same iteration. Here we are going to use latest value or we can say value that calculated previously. And likewise, we can find these values of x and y, and you can see in 5 iteration we are in position to calculate value of x and value of y. So here latest value we are going to use of the variable, where here we are going to use values from the last iteration. Now we will go with second method. So we have this will be in terms of x1, x2, x3. So here you can see this value of 6. So 3 plus 2, 5. So this value is greater. Then we have 6. This is greater than 1 plus 3, 4. And here we have 2 plus 4, which will be 6, which is less than 7. So we have diagonal, so matrix dominant, and therefore we can use this method. Now, for in first, we are going to find value in terms of x1. In second, we are going to calculate in terms of x2. And in third, we are going to calculate in terms of x3. So you can see this. We have calculated, or we have formed the equation in terms of x1, in terms of x2, and in terms of x3. Now we are going to use first Jacobi method. So first iteration we are going to be with all values 0. So now we are going to substitute x2, x1 and x3 are 0. Then first iteration we will get 15 by 6. So we are going to get this value 2.5, then 12 by 6, 2, then 4 by 7 for 0.57. Now for next iteration we are going to use these values. X we have 2.5, y we have 2, sorry, x2 we have 2, and x3 we have 0.57. And by this we are going to get value of x1 1.31, value of x2 we have 1.3, and value of x3 we have minus 1.29. So for next iteration we have to use these values: x1 1.31, x2 1.3, and x3 minus 1.29. And in this way we are in position to calculate the values of x1, values of x2, and values of x3. And likewise, after calculating these by performing number of iterations, at ninth iteration we are very close to our values. So this comes actually values we have, that is 1.75, then we have 2.32, and then minus 1.26. So this is value of x1, x2, and x3. So you can go one more iteration, then you will be very close. It may be 1.76 or 1.75, then 2.33 or 32, and this will be likewise. Now we will go for Gauss-Seidel method. Now what we will do in Gauss-Seidel method? So here we are going to consider value of x2 and x3 as 0. So in first, so we are going to be over here. So I will consider value of x2 equal to 0 and value of x3 equal to 0 to calculate value of x1. So by substituting this, I will get value of x1 that is equal to 2.5. Now when I will go for x2, then I will consider value of x3 as 0. That is my previous value. But now latest value of x1 I have 2.5. So I will put x1 as 2.5 and x3 as 0, and I will calculate value of x2 as 2.5. Now while going calculating value of x3, in that case, we are going to consider value of x1 as 2.5 and value of x2 that will not be 0 now. Latest value I have 1.58. So now I will substitute these two values and I will get value of x3 as minus 1.05. So now when I will go to second iteration, so I will consider value of x2 which is latest 1.58 and value of x3 as minus 1.05 gives me value of x1 as 2.06. Now while calculating x2, so which values I have to use now? I have latest value that is of x1 which is in this iteration only, which is 2.06, and then I have to use value of x3 which is latest value, that is minus 1.05, and then substituting this value I will get value of x2. Now to calculate x3 I have to use latest value of x1 is 2.06 and latest value of x2 is 2.18, and I will get value of x3 as minus 1.26. Now using x2 and x3, these two values which are latest values, and I will calculate value of x1 which will be 1.83, and similarly I will get value of x2 and x3, and then we can have calculate for next iterations. We can have this value of x1 as 1.76, value of x2 as 2.33, and value of x3 as minus 1.26. So here you can see we are going to get these values in 4 iterations only. So this is a little bit less lengthy compared with your Jacobi's method, but here we have to use latest values of the variables. Now we can have next equation, and here also we have to check it first. Is my diagonal is predominant? So I have 1 plus 2, 3. So 5 is greater than 3 plus 2. So we have 8 that is greater. So we are taking mod. Keep in mind. So 8. So that mod should be equal to 3 plus mod of minus 2, which will be 2. And similarly 1 plus 1, 2, and we have here 4. So we can use this method, will give answer easily. So now x1 we are going to get from here. So I will erase all this. Yes, x1 I will get, x2 I will get, and x3. These three equations I will get. And now I will go for Jacobi's. In Jacobi's, I have to first consider all values 0, and then I have to put value of x1, x2, and x3. So from this, I will get value of x2, x1 that will be 12 by 5 because my value of x2 that is 0, value of x3 is 0. Then minus 25 by 8 because x1, x3 are 0, minus 3.13, and 6 by 4 that is 1.5. So now I will use value of x1, x2, and x3, these values. So it is easy actually to understand compared with your Gauss Seidel method. And then we have to substitute these values, gives me x1, x2, x3. Now these x1, x2, x3 in next iteration. So likewise we have to perform the iterations, and then we are going to get values of x1 as 1, values of x2 minus 3, and values of x3 equal to 2. Now when we will go Gauss Seidel method, so now here again I have to consider x2 0, I have to consider x3 0. And by considering these two 0, I will get value of x1 that is 12 by 5, 2.4. But now calculating value of x2, I will take this value of x1 and value of x3 we have to take 0, and by this I will get value of x2. Now while calculating x3 we have to go latest values. So latest value we have x2 value. Now we are not going to consider 0, so we have to consider latest value. So some values from latest iteration, some value from current iterations. Here we have to consider both from current iteration, and we are going to get value of x3 equal to 1.27. Now when we will go for x1, then we have to consider these two values for x1 which are latest values, and then we will get value of x1 1.09. Then we have for x2 this will be x1, this will be x3, and then we are going to get minus 3.2 to 2.03. Similarly we can go for third iteration, and then we will get answer from fourth iteration. So here we require 7 iterations in Jacobi's, whereas in Gauss Seidel we are going to get only 4 iterations. So methods, if you will see, we have iterative same method, but here in Jacobi's we have to use values from same iteration, whereas in this we have combination of this. Latest value of the variable we are going to consider in Gauss Seidel method. So these are the problems which are related with your Jacobi's and Gauss Seidel. I am not going in detail with theory part because it is difficult to cover theory part. So you can have theory part this much, which is sufficient to solve the problems. So thank you. So we will stop here only today.